This single photograph destroyed everything we thought we knew about the birth of the universe. In July 2022, NASA released an image that made astrophysicists around the world go silent. Not because it was beautiful, but because it was impossible. What you're about to see isn't just a pretty space picture. It's evidence that our entire model of cosmic evolution might be fundamentally wrong. And by the end of this, you'll understand why some astronomers are quietly questioning whether we've been telling the story of creation backwards. Let's back up for just a second. When the James Webb Space Telescope aimed at a tiny patch of empty sky, a region smaller than a grain of sand held at arm's length, astronomers expected to see baby galaxies. Faint, messy, chaotic clouds of gas barely holding together. Think of it like this. If you looked at photos of cities from 100 years ago, you'd see dirt roads and wooden buildings, right? The further back you go, the more primitive things should look. The universe should work the same way, except it doesn't. Here's the thing, what Webb saw in the earliest moments of cosmic history looked nothing like baby galaxies. They looked like modern metropolises somehow transported 13 billion years into the past. In that single deep field image, Webb found fully formed spiral galaxies existing just 300 million years after the Big Bang. Now pay attention to this. 300 million years sounds like a long time, but in cosmic terms, it's a blink. To put that in perspective, it takes our sun about 225 million years just to make one lap around the Milky Way. The universe at this point was still practically an infant. According to every model we had, galaxies at this age should be small, irregular blobs, cosmic toddlers stumbling around, barely able to stand. But what Webb photographed were galaxies with clear spiral arms, defined structures, and supermassive black holes at their centers. That's like finding a newborn baby with a full beard and a doctorate. Get this. Some of these galaxies are so massive and well organized that they shouldn't have had time to form. The math doesn't work. Stars need time to be born, live, and die to create the heavy elements that make up later generations. Galaxies need time to pull together through gravity. Black holes need time to grow by consuming matter. But these galaxies already went through all of that in 1/50th the current age of the universe. Scientists were shocked to discover that at least 6 of these early galaxies contain as much mass as our entire Milky Way, a galaxy that's been growing for over 13 billion years. Think about it, these cosmic cities were already metropolises when they should have been empty lots. And that's just the beginning, because the real mystery isn't that they exist, it's how they got so big, so fast. Here's what nobody talks about in those beautiful space photos. Galaxies don't just pop into existence fully formed. They grow through a process. That's supposed to take billions of years. Gas clouds collapse. Stars ignite. Those stars explode as supernovae, scattering heavy elements. New stars form from that enriched material. Gravity slowly pulls everything into rotating structures. It's a slow dance. Except in Webb's images, somebody hit fast forward. Now, the standard model of cosmology, called lambda CDM, which is held up for decades, predicts a specific speed limit for how fast galaxies can assemble mass. It's based on how quickly dark matter can clump together and how efficiently gas can cool and collapse into stars. The galaxies Webb found are 5 to 10 times more massive than that speed limit allows. Most people don't realize this, but that's not a small discrepancy. That's not, oops, we were off by a bit. That's the universe breaking its own rules. One astrophysicist described it as finding a car going 500 miles per hour on a highway with a 60 mph speed limit, and no one can figure out what engine could possibly do that. The truth is, either these galaxies formed through a mechanism we've never seen before, or our understanding of the early universe is missing something huge. Some scientists are now proposing that the first stars, called population 3 stars, were far more massive than we thought. Maybe hundreds of times the mass of our sun. If that's true, they would have burned out and exploded in just a few million years, rapidly enriching their surroundings and kick-starting galaxy formation at hyperspeed. But here's the catch. We've never actually seen a population 3 star. They're completely theoretical. So we're using one mystery to explain another. But wait, because there's something even stranger hiding in that image. Several of these early galaxies are too bright, and this is the part that changes everything. When you look at a galaxy, its brightness tells you how many stars it has, and how actively it's forming new ones. It's like looking at a city at night. The brighter the glow, the more lights are on. But some of Webb's galaxies are glowing with the intensity of hundreds of billions of stars in a universe that's only 300 to 500 million years old. Here's the thing. There simply hasn't been enough time for that many stars to form, even under the most generous assumptions. Think about it. If you're trying to fill a swimming pool with a garden hose, there's a maximum rate water can flow. You can't fill an Olympic pool in 5 minutes, no matter how much you want to. These galaxies filled their pools in what should have been impossible time frames. One research team calculated that to produce the observed brightness, some of these galaxies would need to convert nearly 100% of their gas into stars, an efficiency rate we've never seen anywhere in the modern universe. For comparison, our Milky Way converts about 1 to 3% of available gas into stars. These early galaxies would need to be 30 times more efficient. Now pay attention to this. There's an alternative explanation that's even wilder. What if the brightness isn't coming from stars at all? What if it's coming from supermassive black holes that are already billions of times the mass of our sun? Black holes that, according to our models, shouldn't exist yet. Because here's what they didn't tell you in the press releases. Several of these bright points show spectral signatures consistent with active galactic nuclei. That's astronomer speak for monster black hole eating everything nearby. But how do you grow a black hole to 1 billion solar masses in just a few hundred million years? The math says you can't, unless the seeds of these black holes were there from the very beginning. Which brings us to the most mind-bending possibility of all. Get this. Some cosmologists are now seriously considering that supermassive black holes didn't grow from small ones. They were born supermassive. In the chaotic first moments after the Big Bang, tiny regions of space might have been so dense that they collapsed directly into black holes, skipping the whole star stage entirely. These primordial black holes could have ranged from microscopic to millions of solar masses. And if they existed, they would have acted as gravitational anchors, pulling in gas and dark matter at incredible speeds, jump-starting galaxy formation almost instantly. Think of them as cosmic snowballs rolling downhill, gathering mass faster and faster. But here's where it gets crazy. If primordial black holes are real, they might actually be dark matter. Dark matter is the invisible stuff that makes up 27% of the universe. We know it's there because of its gravitational effects, but we've never directly detected a dark matter particle. What if we've been looking for the wrong thing this whole time? What if dark matter isn't exotic particles, but just black holes we can't see? Black holes that were there from the beginning, shaping everything that came after. Most people don't realize this. But Webb's discovery has reignited this debate. Because if these early galaxies have supermassive black holes at their centers, and there's no time for them to have grown the normal way, then primordial black holes suddenly become a lot more plausible. The truth is, this one image is forcing us to reconsider not just how galaxies form, but what the universe is fundamentally made of. And we still haven't talked about the biggest implication, the one that changes everything about cosmic history. Now, before we go further, I need to tell you something NASA didn't emphasize in their announcements. This image? It's just the first deep field Webb has taken. There are dozens more planned, and early results from follow-up observations are showing the same pattern: massive, bright, shockingly mature galaxies in the first billion years of cosmic time. What does this mean? It means this isn't a fluke. It's not a measurement error or a cosmic accident. The early universe was fundamentally different than we thought. And by now you can see why that difference might mean we've been telling the story of creation completely backwards. But here's what they didn't tell you. Some of these galaxies are so well organized, with such clear spiral structures, that they imply something even more shocking. You know those stunning images of the cosmic web? The vast filaments and voids that structure the universe? We thought that took billions of years to form. Webb's data suggests it was already in place just a few 100 million years after the Big Bang. Here's the thing. The cosmic web forms as dark matter clumps under gravity, creating highways of matter that galaxies form along. It's like cities forming along rivers or coastlines. The infrastructure comes first, then the development. But according to Webb, the cities and the highways appeared almost simultaneously. In our old models, the universe at 500 million years old was supposed to be a mostly smooth, dimly lit fog with just a few flickering proto-galaxies. But Webb shows us a universe already carved into structure, galaxies clustered in groups, voids already emptying out, the skeleton of the modern cosmos already visible. And this is the part that changes everything. If structure formed this fast, then the density fluctuations in the early universe, the tiny ripples left over from the Big Bang, must have been stronger than we measured. Now pay attention to this. We measure those fluctuations using the cosmic microwave background, the afterglow of the Big Bang, and our measurements say they were extremely smooth, variations of only 1 part in 100,000. But if galaxies formed this fast, the fluctuations should have been rougher, more extreme. Get this. Either our CMB measurements are missing something, or there's a mechanism that amplified those tiny ripples far more efficiently than we thought. Some physicists are now proposing that dark energy, the force accelerating the universe's expansion, behaved differently in the early universe. Maybe it was stronger back then, compressing matter faster. Or maybe there were brief periods where it reversed, causing rapid gravitational collapse. These aren't fringe ideas anymore. These are serious proposals published in top journals, all triggered by this one image. The truth is, Webb didn't just photograph distant galaxies. It photographed a paradox. And the deeper we look into that paradox, the more we realize we might have gotten the entire timeline of the universe wrong. Here's what nobody talks about. What if the universe didn't slowly build up from simple to complex? What if complexity was built in from the start? Think about it. Every model we have assumes the Big Bang started with near-perfect smoothness and simplicity. Just hydrogen, helium, radiation, and tiny quantum fluctuations. Everything else, stars, galaxies, planets, us, emerges slowly through billions of years of gradual assembly, bottom-up construction. But Webb's galaxies suggest something radically different. They suggest that the blueprints for cosmic structure were already encoded in the fabric of the universe from the first instant, that the seeds of galaxies, maybe even supermassive black holes, were planted in the Big Bang itself, and that the early universe wasn't a blank slate slowly being written on. It was more like a compressed file rapidly unpacking into complexity. This idea has a name, top-down structure formation, and if it's true, it completely inverts our understanding of cosmic evolution. It means the universe wasn't a baby growing into an adult. It was more like a seed containing the entire tree, just waiting for the right conditions to unfold. Here's the kicker. If this is true, then the question isn't, how did galaxies form so fast? The question is, what designed the initial conditions to make this possible? Now, I'm not talking about intelligent design or anything supernatural. I'm talking about the physics of the Big Bang itself, the specific values of constants, the exact distribution of energy, the particular way quantum fields behaved in the first trillionth of a second. Most people don't realize this, but even tiny changes to those initial conditions would produce a completely different universe. Change one number by a fraction of a percent, and you might get a universe with no stars, no galaxies, no structure at all, or a universe that collapses back on itself in seconds. The fact that our universe produced complexity this fast suggests its initial settings were tuned with extraordinary precision. Scientists call this the fine-tuning problem, and Webb's images just made it a whole lot sharper. But here's where it gets really wild. Some theorists are now suggesting that we might be seeing evidence of a pre-Big Bang state. Conditions or structures that existed before the universe as we know it began, and left an imprint on everything that came after. It's speculative, it's mind-bending, but it's no longer considered fringe science. Because this one image has forced us to ask questions we thought were settled decades ago. This photograph contains galaxies that shouldn't exist, black holes that shouldn't have formed, structures that shouldn't be there, and in doing so, it's rewritten the story of the cosmos. So, what does all of this mean for the future? First, we're going to get more of these images. Webb is just getting started. Over the next decade, it'll photograph hundreds of deep fields, each one peering into a different patch of the early universe. If the pattern holds, if every deep field shows the same massive, bright, impossible galaxies, then we're not looking at anomalies. We're looking at a new cosmic reality. Second, this is going to force us to rewrite cosmology textbooks. The standard lambda CDM model has been the backbone of our understanding for 30 years. It's predicted almost everything we've observed, but it didn't predict this. Now, does that mean lambda CDM is wrong? Not necessarily. It might just be incomplete. Maybe we're missing a phase of ultra-rapid star formation in the first few 100 million years, a cosmic dawn far more violent than we imagined. Or maybe dark matter interacts in ways we haven't accounted for, clumping faster under certain conditions. Or maybe, just maybe, we need entirely new physics. Third, this changes how we think about life in the universe. If galaxies and stars formed this quickly, then planets could have formed early too, which means there could be worlds out there that are 13 billion years old, worlds that had a 10 billion year head start on Earth. Think about it. If intelligent life arose on one of those worlds even just a billion years before us, what would their civilization look like now? What could a species accomplish with a billion-year technological runway? The truth is, Webb's image doesn't just change our past. It changes our sense of what's possible in the present and what might be waiting for us in the future. So here's where we stand. One photograph, hundreds of impossible galaxies, and a cosmos that refuses to follow the script we wrote for it. This is what exploration looks like. Not confirmation of what we already believe, but confrontation with what we can't explain. And that's exactly why we built the James Webb Space Telescope. Not to prove we were right, but to show us where we were wrong.